Hi all, welcome to my YouTube channel Easy Coding with Ankit. Today's topic is find index using recursion. Let's get started. So we will find index using recursion. There are three different topics. First is to find the first index from starting index. So you can see I have an array which contains 6, 8, 1, 8, 3, 4. We will try to find 8, element 8. So you can see it is available at first index. Zeroth index is 6, first index is 8. So we will return first first 1 in this case. Second scenario, find last index from starting index. So from last index we have to find from starting index. So we have to search in a way so that we'll get the last element. The last element is at fourth index. I have already um, colored this index with yellow color, so you can see for first case it is at first index, second case it is at fourth index. Third scenario, find all the indices from starting index. So we will find all the index and we will store those value in the array and that array will return. So here 8 is at two place, at first index and at fourth index. So these two value will be stored in the array and that we will return from the array. That will return from the function. So let's write the code for this and we will use recursion for this one. I will write logic in Java language. I have already created an array. Array contains 6, 8, 1, 8, 3, 4. So you can see 8 is at third index, first index and fourth index. And our key is basically 8. So this we have to find. So let's start. First we will find first index. So for that I will write a public static. We will return int find. We can write function name as first index. So this we have to return first index of the element. We will take multiple arguments. First is we will have array. Second, we need index from where we will start searching. So we already said we will start searching from the first index. So we can take some index value and that when we will call this method we will pass as a 0. So this value will be stored into this in idx. And the third one is we need key or we can say data. So this data we need which we are trying to find. So these three argument will be there and inside this we are using recursion. So we will call this method again and again. So first we will write if array dot idx equal to data. That means you got the element. You got the element, then we can return directly idx. This is the first part where we let's say you are passing zero index value. At zero index it will check if data is there or not. If it is there, then we'll return a 0. If it is not there, that means else case, we will call this method again with next index value. We will starting with 0, then next index value will be 1. So this will also return something. So we will call the same method, recursion method, and here we will increment the idx value from 0 to 1. Like that it will keep on continuing. If it is able to find the data, then it will return the index. If it is not there, then it will try to go to next index. We will have a base case. This is our logic. We have to add base case. Base case will be there when you reach at the end of the array. That means you cross the last element and there is no element. In that case we can say we have reached a we like check with all the element and we have not found any element. So what we can do, we can write logic array dot length equal to idx. If this idx is equal to array dot length, that means you are reached at the end of the array and you have not found anything. Then we can return -1. That means you have not found any element and then we have to return -1. So that's the logic for finding first index of any element, and we are starting from first element. We are starting from starting index basically. Let's call this method and see what we are getting response. We should get 1. We are trying to find 8. So first index array will be same, index value will be 0, and key will pass as a key. Let's call this method and see. You can see I got an index value as 1 and 8 hit at first index. So that means this function is working fine. And what is the time complexity of this function? It is big of n, because we are starting from the starting index and then we are reaching at the last index. That's all, and we are returning all the elements. So we are fine checking all the elements once. So you can say it's a time complexity is big of n and space complexity is constant. We are not storing any value here inside this recursion. Sorry, it's constant. So that's about finding first element. Let's find last element. We will create a new function called public static int last index. Here also we'll take same argument int array, int idx, and int data. Now we need to find last index, and we are using recursion. So what we can do first, as we are starting from starting index, so first we will go to last index of the array. First we will try to reach at the last index. For that, what we can do, we can call this same method again, and we'll just increment the idx. So this way we are keep on going increasing the index, and once we will reach at the last index, we can add a base case. That means if array.length array.length equal to idx, then we can return -1. That means you are reached at the last index, and this last index will also return some value we can store into index. Now we have reached at the last of the array. Now once it will come back, because in recursion we know that first we will call and then it will return something, then it will come back to the previous call. So once we come back, that time we will start searching the element and check if you are finding an element or not. Here we were searching while calling, while building the stack. Like we have discussed, when we are call recursion, we have two scenarios. First, when stack is getting built because you are calling the recursion, and that time you can perform some logic. The other thing is when stack is falling, when you are returning from any function to the previous call, that time stack is falling. In that scenario, also you can write your logic. So this part is when we here in first index method, we are trying to build our logic while stack is getting built. Here when stack is getting failed. So when stack is getting failing, then we will write our logic. Our logic will be if first you can see we are returning -1. So first we can check if idx equal to -1. That means you are just came from the last index. So here you can write a logic and check if any element is there in the array or not. Array dot idx equal to data, then you can return idx. Else you will return -1, or you can return index, because already index is storing -1. In here also you can add else case. If idx is not equal to -1, then that means it is storing some index value, then you can return directly index, because we don't have to check it again. If you already got the index, then you don't have to try to get or replace this index value. So that's why we are directly returning this index value. That's the logic of finding last index. Let's see if you call this method, what value we are getting. Last index. Starting index will pass 0 and key will be same, array will be same. If you execute this method, you can see I got the fourth index value. So which is correct? It is located at last fourth index. Now, now what we'll do, we will handle the third scenario where we find all the indexes of this element. We can create a separate method, public static, which will return int of array because we can have multiple indexes. We have for 8 we have two index, all indices, and we'll take some argument. First argument will be array. Second argument will be idx because we are starting from 0th index. Third argument will be key or data which we will try to find in the array. And now let's talk how we will do it. First, as we need to send an array, int array, then we have to build this array and then only we can store our element. And what is the size of the array? That is also not sure. So once first thing what we can do, as we have two places where you can write logic. First place, while stack is getting built, that means you are one by one you are calling this method and you are incrementing your index. That time we can what we can do, we can count the index values. How many elements, how many times this elements is available in the array. That count you can get. Once you got the count at the end, we can build our array. Once you build, while stack is getting failing, that time you can put your indexes value in this array. If you do that, then basically you are covering all your scenario in the recursion. First thing, we have to create the array indices. We will store null value and we will return this indices which contain our all the indexes. Inside this, inside this, first we need to get the count value. How we will get the count? Let's add a one more variable here, int count, and this count will increment whenever we will find any element in this array. So what we can check? We can check for array.idx equal to data. That means you got some element. Then we can increment the count. And also we have to increment the idx because we will search in the next index. And this method is returning array. So we will store this into idss and we will call all IDs indices, all indices, and we will increment idx plus 1 and also increment count plus 1. If it is not matching with the data, then we don't increment the count, we only will increment the indexes. So count will not increment, count value will be same only. If you are getting data, then only we are increment the count. Once we reach at the last index, that means if array dot length equal to idx, that means you have crossed the last element and there is no element right now. So there we can build our array. We can name it br base result. We can create array and the array size will be count and this array will be returned. So at the last, when we reach at the last, that time we are creating the array using the same count and we are returning this array. So now array is formed. While building the array, we got the count value. Using those count, we are building the array. Now we have to store all indexes in this array. What we can do, once we came out from here, we got this indices. That means we got this array in this indices object basically, variable basically. Now what we will do, we will just check if array.idx once equal to data, then we will just store this IDSS in this index into IDSS, and this is variable at which place as at count value count, and then there we will store this index value. So that's how we are now storing our indexes in this indices variable array at the count index. You can see, so count value will be here, it will be 2. So like that we will store all our indices into here. Let's try to call this method and see what result we are getting. First we will pass starting index, which is 0. Then we will pass key will be 8 only, and then count we can pass 0. If I call this method, it will return array, so I have to use arrays dot toString to see all the content of this method. I have to call this again, all indices 0, and the last will count value will be also 0. So now you can see I got both the index 1 and 4. So that's how you can see I'm covering all the recursion scenarios. First, we are doing something while building the stack. We are doing something while stack is getting failing. In the last, when we are doing at both the place, and also we are doing some building some logic in the end of the recursion when you reach at the end, and then you are start returning from that recursion. So all three scenario we are basically covering here. So that's about finding index using recursion. Thank you for watching my video. If you like the video, please give a hit and also subscribe my channel. Thank you.